Hello and welcome to episode 2 of our Language Design with OHM series. In episode 1, we built a small programming language with print statements and variable declarations, but each of our expressions were limited to simple numbers, booleans, and strings. In this episode, we're going to continue adding in some operators. So, as before, let's begin with writing some tests, or perhaps let's do something interesting over here. Let's try something and say 5 times 8 plus x times y. And this test fails right now because we don't know anything about these operators. In fact, if you look at this, it sees the 5 and it thinks it's done. It says, okay, I got your expression. Where's my semicolon? So what we need to do here is go into our expressions and say, yeah, one thing that an expression can be is it can be an expression with some operators between them. So a couple of expressions separated by operators. Now, if I do this, you'll see we're going to get that inconsistent arity mark. So we'll just say that this is a binary expression. And we can go ahead here and define our ops. So what are some of the ops that we can have? Let's see. Let's do how about this? We'll do plus, we'll do minus, we'll do times, we'll do division, we'll do modulo or remainder. Well, we'll see how that goes, right? We're going to emerge language design out of here and exponentiation. Actually, slight problem right here. Remember how we had to do float literals before integer literals? Same thing. If I have a star here and a star here, it's going to match the first star. So we better remember to follow our own rules about more complex things first. And there we go. And everything seems to work right over here. But let's look at the parse over here. We have print, and then we have our 5 times. Well, wait a second. So we got 5 times and then 8 plus x times y over here. And so kind of what it wants to do is it looks like it wants to do this x times y first, and then it wants to add. And the last thing it wants to do is this multiplication. So writing things this way, OHM is telling us that it's going to look funny. It's not going to follow our intuition that we should always do our multiplications and divisions before our additions and subtractions. But there is a way to work on that, right? And there is the way to think about it is if you ever have something like 5 times 8 plus x times y, then what you really have here is this 5 times 8 right here. That's a term that's being added to this term over here. So expressions are actually a bunch of terms that are added and subtracted together. And these terms are made up of factors, and factors are things that are multiplied. They're divided together. So a better way to write this would be something like this. We say an expression is a sequence of one or more terms separated by operators like plus and minus. So I'm going to put here a bunch of terms, and or an expression could just be a single term, right? So we need to say sorry about that. I don't know why I did that. An expression is one or more terms separated by pluses and minuses. And a term can be one or more factors that are multiplied together. I've really made a mess out of this thing here. Let me fix it up. It needs to be like this. So a term followed by, plus term, minus term, plus term, minus term. And factors are going to be, terms are going to be a collection of factors. We got our times, we got our divides, got our modulos in here. And factors can be made up of multiple things, which were generally called primaries, which can have at least one, right? Maybe one, but then we may have more and more of them like so. And then here we're going to have primary. And these will be our primaries. And everything passes. Not only does everything pass, let's take a look at how things look. We have our 5 times 8 is here, right? This is 5 times 8. And then down here, we have our x times y. So we have our 5 times 8. We have our x times y. And then they're added together. So we've actually implemented something called operator precedence. We see that our exponentiation has the highest precedence. It's done first. Let's make sure that that's the case. Let's see that if I were to multiply, I would have, yep, we're doing the exponentiation first, C7 exponent 8. Let's make sure that still happens even if we're over here. Let's see, where is x? Yes, we do. 5 to the 7th power is here, which we do prior to the multiplication. So we have operator precedence done. But there's one thing that we don't have done yet, and that is, I'm gonna write this out, 1 minus 2 minus 3 minus 4. When I look at my grammar, I really can't tell whether I should be doing the 1 minus 2 first and then multiplying, then subtracting the 3 and then the 4, because everything's kind of flat. Everything's sort of flat here. So we should probably work on this in the grammar. We should probably find a way to force Ohm to be thinking about doing, if it ever saw 1 minus 2 minus 3, that it should actually take this 1 minus 2 and deal with it as a unit before subtracting 3. So instead of saying that expression is a sequence of terms separated by pluses and minuses, which is actually valid, but it just doesn't give us any indication of the associativity of these operators. Like we want these operators to be left associative in this case, right? We want plus and minus to be left associative, meaning do this subtraction before you do this subtraction. The trick here is to say that an expression is indeed a sequence of terms, but the way these terms are going to be sequenced together looks something like this. I'm going to call this, this is an add or a binary expression, let's say. We can say here that expressions are going to be made up of a bunch of terms, but notice that they work something like this. This whole expression right over here is made up of first this expression minus a 4. So this is an expression, this whole expression has an expression here minus a term. And this whole expression is made up of an expression on the left minus a term, and so on. You can see how it works over here. 1 minus 2 minus 3 minus 4. The first thing I have here is 1 minus 2. That's handled lower in the tree. Then as we go up the tree, now we subtract the 3. And then we go up the tree even farther, and now we subtract the 4. So because the tree is going up from the left to the right, you can see that we've implemented left associativity. We can do the same thing for terms and factors. Let's do it like so. This will be an application of a binary expression. So terms can be all of this, or they can be plain old terms. Now, if I were to say, 1 divided by 2 divided by 3 divided by 4, something's not working right over here. What did I do wrong? Is there an error somewhere here? Print. What did I do? Terms go to, oh, that's not good. This needs to be a factor. And now I have divisions working up here, left associative. First I do 1 divided by 2, then I divide 3, then I divide 4. That looks good. For exponentiation, on the other hand, things are going to have to look a little bit different. I don't want exponentiation to be left associative. I want it to be right associative. And to make it right associative, we want our rule recursion to take place on the right-hand side. So it needs to go something like this. All right, let's make sure to get our arities in order. Now you can see that I first do 7 to the 4th power, then I raise 2 to that, and then I raise 1 to that. And now our operators are in there with the proper associativity, and we can get rid of op now because we're no longer using it. Okay. Any other operators we should add? Yeah, I think maybe, what about 1 less than 2? I definitely want something like this. but let's implement that. These are called the relational operators. We want relational operators to have lower precedence than the rest. So I'm going to take these things that are being compared, and I'm going to write my expressions slightly different. So we'll say expression and then a relational operator, and then we'll call it like a comparee or something like that. I don't really know a good name for these things. I'm going to start it off like this and then just say that a comp is a comp plus or minus some sort of a term. And these things over here should be less than or equal. No, can't do that, right? Less than or equal has to come first. Because if you just put less before the less than or equal, it'll match the less and never match your equal. So let's go with equals. Let's go with not equals. I know everything's failing. We'll get to that in a second. Greater than or equal or greater than. Inconsistency, we'll call this a binary. And now 1 minus 2 works, or 1 less than 2 works. Unfortunately, also, something like this works as well. And I'm not really sure what something like this should even mean. I mean, it's definitely parsing and all that, but it's this big giant left associative mumble of all this stuff, which I really don't like, you know. I would like instead for something like this I don't want this to work. In fact, I want this to be a syntax error. I would love for this thing to be illegal. In other words, I want my relational operators to be non-associative. To make them non-associative, what we do is simply this. We just say this needs to be a comparee or whatever, 2 comparees here, because when this was an EXP, I could generate more and more and more of these relational operators. But by doing it like this, I can't have anything in here with a less than or greater than or anything or equals, and I can't have that here. So this is the way to get relational operators to be non-associative. Now, the last thing I would like to add in here would be ands and ors. So I would like to be able to print X and Y or Z, or X is less than 2 and, you know, Y is bigger than 6 times. I don't know. I'm just making stuff up here to the 100. Just for good measure, put in one of these and one of those. Nice little test over here. I would like this to pass, but of course it doesn't because we don't know what these ands and ors mean. Now, I think I'll follow convention over here and say I want the ors to be the lowest precedence, followed by the ands, and both of these have lower precedence than anything else. So I'd like to start by making lowest possible precedence to be with the ors. And the things around the ors are called disjuncts, like then the thing around the ands are called conjuncts. You ever had a logic design class? You learned about disjunctive normal form, conjunctive normal form. Yikes, right? So I want a left associative or operator. These will be disjuncts over here. This is a binary. We're getting kind of used to doing stuff like this right now. Disjunct. And what are disjuncts? Disjuncts will be disjuncts with an and we'll put in a conjunct here, or it can just be a conjunct. And, ooh, this needs to be in quotes. And then basically our conjuncts can go here. Did anything work? Up. Binary. Oh, almost everything greened up. Something didn't quite work here. 1 and 2. Let's check. Expressions are left associative ors around disjuncts. Disjuncts, disjunct or conjunct with binary. Conjuncts are a couple of comps. Comps have terms. Oh, it's this greater than right here. It did not like that greater than. Oh, because we have, why is that? 2 star y with a greater than right there. What did it not like? Expression or disjunct, disjunct and conjunct. Comps plus plus, primary star factor. Y greater than 6 times 9. Oh, did you see right here? It's that problem we talked about before. We can't have this less than and this less than at the same precedence level, right? So what we could do is we could put parentheses around there. And not quite. Or what did I do over here? Greater than. Oh, nope, the greater thans have to be slightly smaller. So let's do the following. Let's put parentheses around this. I mean, it's interesting, but it's kind of doing what we want. We have an or, and X and Y or Z, or it's giving me a little trouble. Give me a little trouble here. Oh. You know, we forgot. We actually don't have parentheses in here, do we? I mean, think about it. I mean, I can't even print X minus 1 with parentheses. This is a huge omission. Look at that. We don't even have parentheses. Look at that. All this time, you know, it's very easy to think, oh yeah, I put something in there when I didn't. We should allow any kind of parenthesized expression to happen in here. And now things are actually working and as expected. So this is kind of nice. We have programs or sequences of statements, we have prints, and we have variable declarations. We have ors and ands and relational operators and pluses and minuses and multiplicative operators. We have exponentiation. We have a rich set of primaries. We have 4 different types. We have a bunch of keywords. We have comments. Yeah, we're on our way to a decent programming language, but we don't yet have is assignments and if statements and while statements and all that good stuff. So that we will leave until episode 3. See you then.